Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is My Calendar Part 1. So the problem statement goes like this. You will be implementing a program to use as your calendar, and we can add new event if adding the current event will not cause any double booking. Okay, and when this double booking will be happening, a double booking happens when two events have same non-empty intersection. Okay, so let's try to understand what it means by non-empty intersection. So there might be a case that, let's say, one event is starting at s1 and ending at e1. Okay, and another event is starting at the same point e. Okay, let's say s2 and ending at e2. Okay, so see, although there is a overlap of the starting and the ending times of the two events, but it is it is empty basically. Okay, uh, so if it would have been a situation like that, this particular s1 would have been here and e2 would be here, then this is a non-empty overlap. Okay, so this is what, so the equality condition, basically you need to understand is that equality condition is not considered for double booking. Okay, ending of one event is equal to the starting of another event, that is not a double booking because the interval, overlapping interval, should be non-empty. Okay, so some moment is common between both of the events. Okay, this should be the condition, or mathematically we can say that starting and ending points equality is not considered a double booking. So event can be represented as a pair of integers, start and end. Okay, and so yeah, and the reason that double booking is not considered, it is considered as a end is not considered, is that this particular end is not included. Okay, so that's why this is another way of explaining the thing that I was telling you before. Okay, so the range of the real number x such that uh, basically for start and end time, and will not be included in your meetings duration. Okay, the implementation of the calendar class is as follows. The calendar initializes a calendar object. Okay, the constructor, and the boolean book method book will be having two arguments, the start time of the event and the end time of the event. Okay, and you have to return true if the event can be added to the calendar successfully without causing a double booking. Okay, so this is what you have to do uh, in the book method. Okay, otherwise you have to return false and do not add the booking that we are trying to add. Okay, so basically, let's say someone is giving you the start and end times of a meeting, and he is asking you whether you would be able to adjust this particular meeting in your schedule according to previous existing meetings in your calendar. Okay, so, and double bookings should be avoided. Okay, and the start is included, start, that start argument, and end is excluded. Okay, so this is the whole problem statement, and before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the starting and the ending time will be of order 10 is to power 9, and at most 1000 calls will be made to the book method. Okay, so let's see how we can implement this. So see, you need to know about two things because we will be using some inbuilt methods. Anyways, uh, let's consider a meeting that we want to add to our calendar. Okay, and let's consider a meeting happening just before this meeting. Okay, so let's say before meeting. Okay, and there is another meeting that is happening just after this meeting. Okay, or if we arrange the meetings sequentially according to their start times, then let's say there is meeting happening just next to this meeting. Okay, let's call this next meeting. Okay, so let's call this the meeting to be inserted or meet to be added. Okay, so here we are arranging the meetings according to ascending order of start times. Okay, so basically it will help us to fetch the very closest meetings between on the left hand side and the right hand side of the current meeting that we are considering to be inserted in the calendar. Okay, that's why we are maintaining this order. Okay, so although you could have taken the descending order, but the implementation will be a little tweaked there, but here I have taken the ascending order according to start timings. Okay, so what we will be doing is we will be checking if the current meeting is overlapping with either of these. Okay, if there is no overlap, we are good to go and we will add this meeting to the calendar. Okay, now the question arises that how you will be comparing or checking whether the current meeting to be added is, you know, conflicting with either of these meetings, before meeting happening before it or meeting happening next to it. Okay, according to the start times order. Okay, so if there is a situation that, let's say, let's give them start and end times. Okay, so let's say this is one is s1 e1. S1 represents the start time and e1 represents the ending time, and the current meeting is having start time and end time. Okay, and let's say the next meeting is having s2 e2. Okay, so there might be a situation, if the overlap is to exist, then this situation should be there, that this start time overlap with firstly we are checking the overlap with this side. Okay, so this start time of the current meeting to be added should be basically less than or happening before the end time of the closest meeting on the left hand side. Okay, so if the situation is like this, that there is s1, then after that there is somewhere your meeting that you are trying to add s. Okay, or let's take the same color. Okay, so let's say this is the previous meeting s1 e1, and your current meeting is in a situation like this. Okay, so this is for sure that your current meeting will be having a overlap. Okay, and it can be anywhere. Basically it can be here or it can be here also. Okay, not exactly s1, it's s only. Okay, so if there is a situation that the starting of your meeting is before the ending of the previous meeting, then you will say that there is a overlap with the meeting that is happening before our meeting, in if we arrange the meetings in order of start times in ascending order. In that case, you cannot add the current meet. Okay, else it's fine. Now we will be checking for the conflict with the next meeting. Okay, potential conflict with the next meeting, so we will be checking for this particular one. let's say let's take the same colors again. So let's say our meeting is starting at S, and there is another meeting that is if arranged according to the start point is to the very next of our meeting. Okay, and S2 is something like this. Okay, so in this particular case, see, you are able to see that our end of the current meeting that we are trying to add is exiting or greater than the starting of the adjacent meeting on the right hand side. Okay, in that particular case you will say that there is overlap, or the it if we try to add the current meeting, it will result into a double booking and we cannot add that. Okay, so if this kind of situation is there, then there is a conflict, else we are good to go, and we can, if we are past both of the checks while checking conflicts for meeting before and after, then we will safely add this meeting to the our we will be maintaining a sorted order of start times of the meetings, and meetings will be inserted in form of pairs of start and end. Okay, so this can be safely added in that case, and this will be your new order. Okay, so let's see how we can achieve this particular implementation programmatically. Okay, and for that, let's take the code to the board. So this is the implementation. This particular section is of no use, so let's remove that. It's just for the sake of telling you how this thing will be called. Okay, this booking method or book method you can say. Okay, so let's discuss what we are doing here. So see, I have given names so that you are able to understand right away after seeing even the implementation. So closer from right is the meeting that uh, here this is the closer from right. Okay, and this one meeting I am calling closer from left. Okay, so basically we are using some inbuilt data structure tree map. Okay, what does this tree map does is it store key value pairs. Okay, and all the key value pairs are sorted in by default in ascending order according to the key values. Okay, so as we were trying to insert it according to the start values, so it will be arranged in value. So basically all the entries will be arranged in ascending order according to the start value. Okay, so that's why we have used that tree map. Okay, a equivalent implementation will be provided for C++ also, so those folks who prefer C++, they need not to worry about that. The only thing that you have to be clear of is the logic that we are using while checking this conflicts. Okay, so anyways, so see what this ceiling entry will give us. So consider it like that. So there is a particular let's say partition. Okay, so for this analogy, let's consider that there is a jar. Okay, and it is having a lid. Okay, and there are some flies in it. Okay, and the lid is on both sides coated with honey. Okay, and there are some flies on the top of it, so they have a affinity to the honey. So that's why both of the flies from the bottom and the below will be trying to stick to the lid. Okay, so for the ceiling value, you can say that it will be the value that is either or smallest value. Okay, smallest value equal to or greater than current value. Okay, so current value you can consider this lid. Okay, and ceiling value is the fry sticking to the top of the jar. Okay, and similarly the floor value. Okay, let's say the values are increasing this way. Okay, floor value is the maximum value. Okay, max value equal to or less than current value. Okay, so if values are increasing from bottom to up, then this situation or this analogy in a way represents or will be helping you to understand the ceiling and the floor values. Okay, so this is what the ceiling and floor values are. So it will help us to get basically since we are wanting to find the closure from left, so we will be taking the floor value. Okay, because we will be trying to come as close as to this particular value but not exceeding this value. That's why floor entry is there. Okay, and since the entries were arranged according to the start values, so it will get you the closest entry from the left. Similar logic will be applied for the ceiling value. Okay, it will be getting you the closest entry from the right hand side. Okay, but not less than the current value. Okay, so once you are having both of these, then you will be doing these comparisons. Okay, so for the first part, before meeting comparison, we should be comparing s for the start of the current uh, event that we are trying to add or the meeting that we are trying to add with the end of the previous meeting. Okay, so if first of all there should be a previous meeting, the very first condition for the conflict check. Okay, so this is the first meeting. Okay, this should exist, and if it exists, then if it is a case that its ending is, you know, after the start of the current meeting that you are trying to add, in that case you cannot add the current meeting as it will result into a double booking. Okay, similar kind of check we are doing for the closest meeting from right. Okay, and in that case if that particular conflict happens, then we will return false, and we will not add the current meeting as it would result into a double booking. Okay, so a thing here to be noted is we are not considering here the equality because it is explicitly mentioned in the problem statement that it is opened from the end side. Okay, so end is not considered to be the part of the meeting. So then if there is no conflict and we are good to go, then we will add the current meeting to the calendar. In a way we will be adding it to this particular tree map, and then we will simply be returning true, saying that we have successfully added the current entry or the meeting that we were trying to add to the calendar. Okay, and as far as the time complexity and space complexity are being concerned, the time complexity wise, this is basically these functions finding the adding a value will take log of n, and so if let's say there are n entries and we are trying to add them, adding a single entry is taking log of n, and if there are n entries it will take total of n into log of n time complexity. Okay, and space complexity wise, since let's say in the worst case we would be able to add all the entries, all the bookings will be the valid ones, and we would be using that much n space for each of those entries, so it will be order of n. Okay, So these will be the complexities. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems. And I'll be seeing you in the next video. Thank you for watching.